by the common denominator, right? Either one. I think let's do the common denominator one because it's going to be a very similar and I think maybe less amount of work. What is the LCD of the top here? What's the LCD up here? X times x plus 1. What's the LCD down here? It's the same thing, right? That's a good sign to use this. So the LCD of both is just x times. So at this point, you multiply everything by what? So you have, it looks for a second it's going to be worse. It's 6 plus x plus 1 times x plus 1 minus 1 over x times x plus 1 all over 2 over x times x plus 1 minus 4 over x plus 1 times what? X times x plus 1. Does a lot of stuff cancel? This cancels there. The x cancels there. The x cancels there. And the x plus 1 cancels there. Can someone read off to me what I'm left with on top? What am I left with on top, Milo? What's nope. 6x minus 1 times what? Correct. And can someone read off what's left on the bottom? 2 times x plus 1 minus. Yes, correct. And can you simplify this a little bit? Yeah, 6x minus 1 over 2x plus 2 minus 4x. What does that simplify to? 5x minus 1 over what? Over what? Someone jump in. What is it? Negative 2x plus 2. Is there anything else you can cancel? Is this an equation or is it a expression? There's no equal sign, so it's an expression. You are done at this point. Voila, you are done. What are you trying to do when you solve this? You could factor, but you're going to factor and then find what immediately? Domain. So if you factor this, you end up with 3 over y minus 3 because that can't be factored. But can you factor the next denominator? Someone raise their hand and tell me what it factors into. Alex. Correct. Equals 2 over y minus 2. So can someone tell me what the domain is? Someone raise their hand and tell me what the domain is. 100% correct. Hannah, what is? Mar, what is it?
Y minus 3 times y minus 2.
That is not the domain. Someone tell me what the domain is. Hey, Aubrey, what is it? That's what's not in the domain. You're getting closer now. X such that
X cannot equal. Yeah.
Cannot equal what?
And then
2 or 3. The domain is everything besides 2 and 3. Besides 2 and 3. The domain isn't 2 and 3. That's the exact opposite of what the domain is. Now that we found the domain, we multiply by the LCD. We multiply everything by the LCD. Can someone tell me what the LCD is?
Wasn't that what I just said?
What? Say it again.
Y minus 3 times y minus 2.
Correct. So if we multiply everything by that, what are you left with? 3 times what? Y minus 2 minus 3 equals 2 times what? Yeah, that's the y minus 3 is left because it cancels. Is that a lot better than what we just had? Yeah. Now it's just a matter of distribution and simplifying a rather straightforward 3y minus 6 minus 3 is equal to 2y minus 6. 3y minus 9 is equal to 2y minus 6. Subtract 2y, you get y minus 9 is equal to negative 6. So what does y equal? 3. Now, what's the last thing you do when you get an answer? You want to check to see if it's in there, but look, can it be 3? Well, excuse me, by the way, there was no x's in this, so what should we have said instead of x? Y such that y, right? The thing is, y cannot equal 3. You can't equal 3, right? So what's the answer to this? No solutions. But you would have to do all of this to show that there are no solutions. You did the math, and you said that the only answer it possibly could be is 3. But what did you find at the beginning of this problem? It can't be 3. Graphically, we never get into this, but what this looks like, it means that when this graph, when you're graphing this function, it's traveling along, and then at that point, there's an empty dot. And what is it? What is the y value there? Y equals 3. The function isn't defined there. We don't get into that in this class, but it just isn't defined there. So what's the final answer here? No solutions. Well, no, it's not. Prime only has to do with factorization. No, it just means that there are no solutions. Multiply by, first of all, what's the domain? T. Correct. Now go on. What do I multiply by? What's the LCD? 17. Multiply everything by 17. What are you left with? 5 equals 52 times t minus 3 times 7. So what do you end up with? 5 is equal to 52t minus 21. So 26 is equal to 52t. So what does t equal? A half. Is a half part of the domain?
Yes.
Yes, it is. It is in the domain. What's the only number that's not in the domain? So the answer is t equals a half. Yes. Extension of what we've been doing. That's all 7.5 is. Oh, that is pretty nasty, isn't it? Okay, hold on. Write an equation first thing. Do not try to write an equation first thing. You need to first answer the question, what information do I need to answer this question? So what are you looking for? Are you looking for color? Are you looking for what type of chicken? No, you're looking for how many million Americans. So once you've identified what you need to find, you need to do what with that? You need to pick a proportion. No, before you do the proportion. Variable. So let's say x is equal to how many million Americans have no health insurance. So that's x right there. Now we can start writing our equation. We know that the proportion is 15 over 100. And we know that that has to equal what? Can someone tell me what the other side of this is going to be? Raise your hand. What's the other side going to be, Alex?
X over 302 million.
302. We'll leave it in millions. Just keep it like that. Absolutely. Here's the deal. Once we have this, is that rather easy to solve?
Yes.
Fraction equals a fraction, so what can you automatically do?
Wait, if we're keeping that at 302, we have to make it point like.
Nope. You keep it like that. Just remember that whatever answer you get is going to be in millions. That's all you need to remember. So what do? We cross multiply. So we end up with 100x is equal to 15 times 302. So what does x equal? 15 times 302 all over what? 100, exactly. Now, would you need a calculator to get that answer? Sure, but are you done at this point, effectively? This is how many millions of people do not have health insurance, which is kind of staggering. So the idea here is you are going to be building rational functions, but here's the thing. Are the rational functions you're going to be building like super duper crazy? No, they're really not, especially the ratios. The challenge, the work, comes from building these equations. The equations themselves are not going to be super complicated, but you need to be careful because small change. Write me an equation, but make sure you label a variable first and then write an equation and stop. So what are you trying to find? What's that last sentence right there? How many more gallons will she need? So you're going to call that what? What variable do you want to call it? Let's call it x. Okay. Can someone tell me, if they're relatively confident, what the equation is we're going to solve? Mar, what do you think it is?
10 over 210.
Yep.
Equals x over 640.
Who thinks that's correct? It's really close to being correct. It's really close. You're really close. Mar, let's see if Mar can figure it out. Mar, you did incorporate something in there. What's the beginning of the second sentence say?
She had 5 gallons of gas in the car.
So where does that come into play in your equation? Ah, so what are you going to need to do? X plus what?
X plus
Ah, there it is, right there. Small things matter. So if you had solved the other one, you would have gotten how much gas total it takes. She wants to know. No, because X represents how many more gallons. How many more gallons? How many more gallons? The 5 is already there because that's going to represent, it's going to be spent. It's going to be spent. How many more gallons will she need? It's added to the 5 that are already in there. It's added to the 5. Mar, what'd you get for X?
25.5 gallons, approximately.
Anybody get 25.5? We got a vote right there. Well, let's do it out. 210 times x plus 5 is equal to 10 times 640. So 210x plus 1050 is equal to 6,400. So x is going to be equal to 6,400 minus 1,050 all over 210. You have to do that on your calculator. You have to do that on your calculator. Did anybody get 25.5?
Yeah.
Good. What relationship we're going to be working with here? What's the relationship between distance, time, and rate?
D equals R times T.
D equals RT. That's the core relationship here. So this problem says you have a trip going one direction up a river, and then you go back the same way. And it says the paddle wheeler goes 10 miles against the current, which means the current is working for or against the thing. If you're going upstream, does that mean you're working, is the current helping or hindering? Hindering. And then you go on the same time that it goes 15 miles with the current. If the rate of the current is 3 miles per hour, find the rate of the boat in still water. So again, what is the first thing you always do? Yeah, figure out what you're trying to answer, what you need to answer the question, label that as your variable. So in this case, it's the rate of the boat in still water. What do you want to call that? X? Absolutely. Now, what did we like making when we had distance equals rate times time word problems?
I like the
Table. Yeah, absolutely. So we have upstream trip, and we have downstream trip. We have distance, rate, and time. What's the distance going upstream? It tells us. 10. What's the distance downstream? 15. What's the rate going upstream going to be? What's the rate going upstream going to be? That's the...
again, so minus.
A minus, so it's going to be R, what? Minus 3. And what is it downstream? Oh, no, we used X, right? X, yeah, sorry. X minus 3 and X plus 3. Now, here's the deal. At this point, we're going to fill in time. On this equation right here, what does time equal?
D times R. Oh, wait,
Nope. D over R. Time is equal to D over R. So what is time going to be here? 10 over?
X minus 3.
And what's this one going to be?
15 over X plus 3.
And what do you know about the time of these two trips? Look at this. You see this phrase? Same time. So what equation can you write, Mar?
10 over X minus 3 equals 15 over X plus 3.
Correct. And then would you solve for X? That right there, building the equation, that's 90% of the work. Because is that have you solved much more complicated rational equations? Yeah. That right there is another cross multiply, solve for X. But what's the key thing to realize right here? Time is equal to what? Distance over rate. And then you set them equal to each other. You set them equal to each other. Who got X equals 15? 15, we got that seconded. Any thirds? Oh, nice. Okay, very good. We know it's 300 and 300. We called, what are we trying to find? Their walking rate, so let's call that X. So if you're stationary, it's just X. But what's your rate with the stationary, with the moving side of it? X plus what? 1. You're 1 meter per second faster. So if you just took it from this right here, what is time equal to? Distance over rate. So what's time equal to here? 300 over X and what? But what do you know about these two times? It tells you something about these two times. They're not the same.
Moving one is 50 seconds faster.
So how do you make them equal? Yes. Bingo. There it would be. Okay.